Hey, yeah, what up? Basically, this is video number 3, or the solutions to those level 1, 2, and 3 problems. I'm going to do my best to walk you guys through a few of the examples. And if you have any questions, definitely feel free to reach out to me. If you're a viewer who isn't one of my students, definitely drop me a message or an email, and I'll try to get back to you. Yeah, I hope this helps. Alright, cool. So what we're going to do, these are review problems. What we're doing is we're looking for the inverse sine of negative 1/2. So what question do we have to ask ourselves whenever we're trying to solve a problem like this? Well, the question that we need to ask every single time, specifically for this one, we should ask, what angle theta gives me a sine value equal to a negative 1/2? So what angle theta gives me a sine of theta equal to negative 1/2? Well, there's several things that there's several things that you have to do. First of all, the first thing that you have to do is ask yourself, what quadrants for the inverse sine function can you go shopping in? So what quadrants? You should know that off the top of your head. You know that's from negative pi over 2 to pi over 2, so that's quadrants 1 and 4. Alright, well, the second thing that you should ask yourself is, okay, well, where is this gonna, where is sine gonna be equal to negative 1/2? In the first or the fourth quadrant? Well, fourth quadrant. Put a box around the fourth quadrant. Next thing that you do is you draw your special right triangle. So, when you draw your triangle in the fourth quadrant, you ask yourself, okay, well, I know that I have some value for theta. That's my angle theta right there. Yeah, you can see. So I know that I have, I'm going to go ahead and draw this to the right over here so you guys can see a little more clearer. Fourth quadrant. I'm going to have a triangle, and I know that I have to have some value theta that I'm solving for. Well, if I know that the sine of some angle theta gives me a negative 1/2, sine I know is opposite over hypotenuse. So opposite has to be negative 1/2 over hypotenuse, which is 1. What's my adjacent have to be? Well, positive square root of 3 over 2, because I know that this has to be a 30, 60, 90 triangle. This is a special right triangle that has my theta value. What does my theta value have to be if the opposite is a negative 1/2? Well, if the opposite is a negative 1/2, my theta value must be negative 30 degrees. We know this because opposite of 30 degrees, when we did SOHCAHTOA in our special right triangles a couple units back, opposite of 30 degrees is negative 1/2. So theta is equal to negative 30 degrees. Do I like degrees? Yeah, I like degrees, but do I love degrees? Nah. So in order for me to be in love with degrees, I have to convert them to radians. So negative 30 degrees, I convert it by multiplying it by pi divided by 180, which gives me negative pi over 6 radians. So my theta, so the inverse sine of negative 1/2 is equal to negative pi over 6, or the angle of theta, where the sine of theta is equal to negative 1/2, is a negative pi over 6. Cool. Next problem. So that's all we had to do for number 1. Next problem. The exact same thing. Well, if we're dealing with the arc cosine, this is the same thing as the inverse cosine of x. So we have to ask ourselves, we have to go through 2 steps. First step, what quadrant is inverse cosine going to be negative? Well, which quadrants does it work in? It works, which quadrants is the inverse cosine actually a function? Those are quadrants 1 and 2, because we know, based on the graphs that we did, that the inverse cosine graph checks out. We can go shopping in the first and the second quadrant. So if we go shopping in the first and second quadrant, where is my cosine going to equal negative square root of 2 over 2? My cosine is going to equal negative square root of 2 over 2 in the deuces quadrant. Numero dos. So Now what do? Draw my special right triangle. So let's go over here, draw the special right triangle, second quadrant. Well, we don't know if we can draw a special right triangle. Let's just check it out and see what we get. So if we're in the second quadrant, and we also know that we're looking for the angle of where the cosine of some angle theta is equal to a negative square root of 2 over 2. The cosine of this angle is theta, but we know we're looking for this angle. The cosine of that angle has to be negative square root of 2 over 2. Cosine means adjacent over hypotenuse. So negative square root of 2 over 2 would be on this side over 1. Do I know any 30, 60, 90 or 45, 45, 90 degree triangles that will give me the adjacent value to be negative square root of 2 over 2? Bada bing! Yes, 45, 45 degree, 45, 45, 90. So my 45 degree triangles, my 45, 45, 90 degree triangle is the triangle that I'm going to use in order to obtain like the angle that I'm looking for. So can I just say that the arc cosine of negative square root of 2 over 2 is equal to 45 degrees? I don't know, what can I? No, I cannot. Why can I not? I cannot because when I take the cosine of 45 degrees, the cosine of 45 degrees would be in the first quadrant. Cosine of 45 degrees would be in the first quadrant. Is that going to be positive or negative? That's going to be positive. Well, the angle theta that I'm looking for is actually 180 degrees minus the 45 degrees that we have here. So the angle theta that I'm looking for is 180 degrees minus the 45 degrees that we already have, that we found for our special right triangle. 180 minus 45 degrees, that gives us 135 degrees. What do I have to convert those to? Radians. Let's do it. So 180 degrees minus 45 degrees, that gives me 135 degrees, which is equal to, I multiply it by pi divided by 180 degrees. That gives me 135 pi over 180, which gives me 3 pi over 4. So my answer is 3 pi over 4. Can I check that answer? Heck yeah, I can check that answer. I'm going to check that by saying, all right, well, if I take the cosine of this value, so if I take the cosine of 3 pi over 4, will I end up with whatever I started with in these parentheses? Will I end up with that? Let's check it. So cosine of 3 pi over 4, you do it, work it out, do a special right triangle, you'll get this exact same diagram. Cosine of 3 pi over 4, this will give you pi over 4 or 45 degrees. Cosine of that, negative square root of 2 over 2. We're good. Next problem. Let's do it. So I'm going to do number 3. Number 3 and number 4 were slightly, they were about medium difficulty. They weren't too bad. You guys can handle it. Great. So now, let's do it. No, I'm just kidding. Anyway, yeah, let's do it. I know you guys are probably cracking up. Anyway, so the inverse tangent of 0. So you're asking yourself, for what value, for what angle theta, will the tangent of some theta or some angle theta equal 0? So when will the tangent of theta equal 0? That's what you're asking yourself, and you're looking for theta. First thing that you do, where's the inverse tangent of function? Where's the inverse of tangent of function? Quadrants 1 and quadrant 4. Where is the where's the inverse or where's the tangent of theta equal to 0? Well, that's a little tricky. That's a little tricky. Maybe it's a little hard for you to think like, okay, well, what does tangent of theta actually mean? Well, we know that the tangent of theta is actually just the sine of theta divided by the cosine of theta. Well, if that's the exact same thing as the sine of theta divided by the cosine of theta, can I figure out what my theta value is? Yeah, I can. Wow, that's pretty cool. So, what do? Draw my special right triangle, or draw my triangle, if I can draw a triangle. Well, I know that it can only be in the quadrants 1 and 4, so I'm going to think about those two quadrants. That's what I'm going to think about first. I'm going to think about these two quadrants. These are the possible quadrants that it could be in. All right. So, can my denominator ever be 0? No, my denominator can never be 0. So my cosine of theta can be some number, can be any number, but it cannot be 0. What will my numerator have to be for my function to equal 0? What will my numerator have to be so this equation equals 0? What will this have to be? The numerator has to be 0. So if I'm saying that I'm trying to find the tangent of theta of some angle to be equal to 0, and I'm looking for an angle theta, well, the easiest thing that you can look for is you can say, all right, well, I know that it has to be in the first and the fourth quadrants because that's what values that tangent qualifies for. I also know that I can never have a 0 in the denominator. But in order to have something in order to have a fraction equal to 0, I know that that theta value, or I know that my numerator has to be equal to 0. So I know that whatever I get in the top has to equal 0. My bottom can be whatever I want it to be. But what angle of theta is the sine of theta equal to 0? What angle of theta is the sine of that angle equal to 0? Well, I know that the sine of 0 is equal to 0. So say if theta was 0. So let's see if that works. So the sine of 0 degrees divided by the cosine of 0 degrees. 0 divided by 1 equals 0. So I know that my theta value equals 0, which totally works for answering this question. So the sine of theta, or the sine of has to be 0, so the sine of 0 degrees is equal to 0, and the cosine of 0 is equal to 1. 0 divided by 1 is 0. So that checks out. So what did my theta value equal to? Theta equals 0 degrees. Do I like degrees? No. 0 degrees, same thing as 0 radians. Good? So the last problem for this first section, and then you will be on your own to do the rest. So the last problem, arctangent of the square root of 3. The arctangent of the square root of 3. I'm asking myself, what angle, theta, does the tangent of that angle equal to the square root of 3? Well, I know, first of all, that tangent is in the first and the fourth. The inverse tangent is going to be in the first or the fourth quadrants. Well, where is it a positive? Tangent's going to be positive in the first quadrant. Tangent's positive in the first quadrant. So I know that I don't go shopping in the fourth quadrant in this problem because it has to equal a positive value, a positive square root of 3. Second thing I do is draw my special right triangle. Draw my special right triangle. After I draw my special right triangle, what special right triangle has a square root of 3 in it? 30, 60, 90. Okay, well, how can I draw that triangle to where, so what you have to figure out is how you can draw that triangle to where you can put the sine of some angle divided by the cosine of that same angle to be equal to the square root of 3. You're going to have your numerator, so you're going to have your opposite is going to be square root of 3 over 2, and your adjacent could be 1/2. or it could be flipped, but you have